Hello, ladies and gentlemen. Today we're going to be taking a look at some solids. So we're going to be thinking three-dimensional. You're going to need your notes, which is that little foldable that we made in class, your pen and pencil, and of course your thinking cap needs to be on. I'm sure it's always on. So, like I said, we're going to be getting into the world of solids, so three-dimensional shapes, like a prism, a pyramid, a cone, a cylinder, a sphere. These are all things you're probably familiar with. But the way we work with them now at the geometry level might be a little different than what you've done before. This is a picture of your foldable. You made this in class. Please make sure that you have these headings on the little flaps on the side and also on the very front cover. We're going to be talking about polyhedron today and what they are and what that means, as well as Euler's theorem. Okay, so we're going to be taking a look at how these relate to our solids. So this is where your notes are going to go today. There's really just two things. We're going to work on that front cover there, the polyhedron idea, and then that theorem there that's going to relate some faces, edges, and vertices for us. So first thing we need to take a look at. On the front cover, would you please add this definition in there? The polyhedron. It is a solid three-dimensional shape. It has flat faces and cannot have any curves. So you saw all those pictures of solids at the beginning. Some of them are polyhedron and some of them are not. Now when we think about polyhedron or these three-dimensional shapes, we're going to be thinking about how they're constructed or what they're made up from. And solids are going to have sides, and they're going to be called faces that are polygons. Okay, so the sides themselves are faces of that three-dimensional shape. Then we might have something where it's called an edge, and that's where those two faces come together or meet. And then we're also going to have a vertex, and that's that pointy part that we're familiar with. It's a point or three or more edges will come together to meet. So let's take a look at what this looks like in three-dimensional picture land here. And you can see that the pink represents a face. That's the flat surface, the polygon face. And the edge is basically the line or the segment I would use to draw it. This right here is an edge. This right here is an edge. Where those faces come together, those are edges. And a vertex is the pointy part. This guy right here, here, and here. Now on a polyhedron, because all of the sides are flat, we can count the vertices, the faces, and the edges. But some shapes are not considered polyhedron. We're still going to work with them, but we're going to be looking at them a little bit differently. So let's start with this first one. Don't write this part down, but what am I? What is this thing? This is a cone. Is it a polyhedron? The answer is no. Because it's curved, it's not a polyhedron. It's still a solid. We're still going to work with it. We're still going to find the volume of it and those types of things, but he's not considered this special classification of polyhedron. What about this? Is this a polyhedron? Well, this is what we would call a rectangular pyramid. Now you might be saying, I don't see too many rectangles on this. We'll see a rectangular pyramid is named that because of the rectangle on the base. It's a pyramid because everything comes up to meet at this point up here at the top, and all the sides there on the sides, the lateral faces, are triangles. So he's considered a rectangular pyramid. Is he a polyhedron? Yes, because he does not have any curves, okay? He's a solid with no curves. Is this a polyhedron? Well, this is a cylinder, and he's curvy, so no, he's not a polyhedron. What about this? On the base, if I outline it a little bit more so you can see it, the base down here has 1, 2, 3, 4, 5 sides. That's a pentagonal pyramid. It has a pentagon at the base, and again, it comes up to meet at a point up here. A pentagonal pyramid. Is it a polyhedron? Yes, because all of those flat sides there are polygons. What about this? This would be what we would call a prism. A prism that actually has a square base. The bases are actually on the sides here. He's kind of toppled over. So he might be considered a square prism. He might be a rectangular prism if some measurements are given. We'd have to know a little bit more. Is he a polyhedron? Yes, he is, because he again does not have any curves. What about this? This is a sphere. Is he a polyhedron? No, he's curvy, still a solid, but he's not considered a polyhedron. So basically what you saw there as I was going through all of those examples is that prisms and pyramids are named by the shape of their bases. So when we look at prisms like these two, They're not pyramids, they're prisms, because the base is a special shape like a rectangle, or in the green one here, the bases would be considered the triangles. It has two distinct bases and the rest of the sides are rectangles. So the two shapes here that are the base are the triangle in the front, triangle in the back, because all three other faces are rectangles there. So we talk about the names of these based on what that base needs to be. Now, bases will be parallel and they will be congruent. And we can also look at the same idea with pyramids. Pyramids will also have a base, and that's how we describe them. We have a square pyramid who has a square on the base, and we have a triangular pyramid who would have a triangle on his base. We'll learn more about that as we work through our work in the coming weeks. So now we should take a look at some polyhedron, or see if they are polyhedron, name it, and then find the number of faces, vertices, and edges. You don't need to write this part down, but please watch. This guy right here, is he a polyhedron? Yes, because he has no curves. What is he? What's his name? This would be a triangular prism. Again, because there are two sides that are triangles and the rest are rectangles, he is considered a triangular prism. Now if we were to count the number of faces, vertices, and edges, let's start with faces first. Faces are those flat surfaces that make up this shape. So how many faces would it have? Well, there's two triangles, front and back, and then there'd be three rectangles if I followed all the way around. So two triangles, three rectangles together makes 5 total faces. Then if we look at vertices, vertices are those pointy corners. 1 pointy corner, 2 pointy corner, 3, 4, 5, 6. There are 6 vertices. And now edges. Edges are those lines that we would use to draw. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 edges total. So we just counted, we said what he was called, and then counted those beautiful faces, vertices, and edges. This is the same sort of deal. This one right here is a pyramid. He has a square base, so we would call him a square pyramid. Is he a polyhedron? Yes, because he has no curves. Let's go ahead and talk about the faces. How many faces would it have? 1 on the bottom and 4 around the sides, so that'd be 5 total. Vertices, pointy corners, 1, 2, 3, 4, 5. 5 vertices where those edges come together there. And then edges, if we draw the lines, 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. So that's how we would go ahead and count all of those pieces. Now sometimes you want to know if you counted correctly. So let's go to the front of your little foldable there and make sure that you have this formula. There's a relationship between the number of faces, edges, and vertices on a polyhedron. And it's related by this formula. Faces plus vertices equals edges plus 2. So if you ever want to check to see if you counted correctly, this would be a good formula to use. So make sure you have that on the front of your lovely foldable. Now let's see if we can use that to check this one. We're going to go ahead and count those faces, vertices, and edges and see if we counted correctly by checking using that theorem. So let's count. I have faces. Faces on a cube here would be 6. Vertices would be the pointy corners, 1, 2, 3, 4, 5, 6, 7, 8. And then edges. So edges would be those lines we use to draw it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total. So let's check with that formula. The formula says faces plus vertices equals edges plus 2. If we plug in our numbers, 6 plus 8 equals 12 plus 2. Is that a true fact? This side is 14. This side is 14. So yes, my numbers check. I know I counted correctly. So that kind of summarizes what we need to do today, and just take a look at the basics of these solids. I want to thank you for taking good notes.